Okay, for the third problem this week, let's do problem 6.79. We have a banking situation. Banks make money by lending money at prices higher than what they pay for money. Let's say you take out a loan for 6%. Well, maybe at that time the bank is paying its depositors, who have savings accounts and CDs and so forth, 2%. The difference between 6% and 2% is the bank's profit, or 4%. Now, in this problem, someone did a survey and found that the average spread, average distant difference between money, the amount charged for loans and the amount paid to depositors, was 4.15%, and the standard deviation was 0.5 percentage points. Now, don't let percentages fool you. These are just numbers. The mean is 4.15. The standard deviation is 0.5. Now, I've drawn a normal standard distribution curve. The values along the x-axis are z values, so the z value of 0 in the middle corresponds to our mean, or 4.15%. Now, I've made some little labels here. I'm just going to, in the interest of time, move those in. You could go to the insert menu and put in a text box and do it yourself, but there's 4.15% in the middle. Now, the values of z greater than 0, 1, 2, and 3, and so forth, and the value are number of standard deviations greater than the mean, and the negative values are number of standard deviations less than the mean. So a value of 2, for instance, is 2 standard deviations, and in this particular case, 2 standard deviations would be 1 full percentage point greater than the mean, or 5.15%. Okay, the first problem we're asked to do is to find the probability of picking a bank at random and finding that its spread is 5.4% or greater. Now, the first thing is we have to figure out where that is in relationship to z. So to do that, we take the value we're interested in, which is equal to 5.4, and subtract from that our mean value of 4.15%. That says that the value we're interested in, 5.4%, is 1.25 percentage points greater than the mean. But that's not what we really need to get a z. We have to find out what that 1.25 percentage points is in terms of the number of standard deviations. Well, to do that, we simply take the difference, 1.25, and divide that by the standard deviation. And we find that the point we're interested in, the z value we're interested in, is really 2.5. So right here, 2.5 corresponds to 5.4%. So let me move in my label here and put it about halfway between 2 and 3, good enough for what we're doing. So that's our z value. Now, we're interested in banks who have a spread greater than 5.4%, which means we're interested in the area under the curve to the right of 5.4%. Now, table 6.1 that you find on page 251 and 252, flip to page 252 and run your eye down until you get to the 2.5 row and move across to the first column, which is the 0, 0 column, and we find a value of 9938. So I'll type that in here, 0.9938. Yeah, 0.9938, and that's the table from the value from the table. But what that is giving us is the area to the left of that value, this area here. What we're really interested in is the area to the right, because we want to know what percentage of banks have a spread greater than 5.4%. So because the area under the total curve is 1, we can simply subtract the z value from that value of 1 and get 0.0062, which means the probability of picking a bank whose spread is 5.4% or greater is 0.62%. Not very likely. Okay, part B asks us to find the probability of getting a bank whose spread is less than 4.4%. Now, we know 4.4% is still greater than 4.15, so we know it's going to be somewhere in here, but we need to know the exact z value. And to find that, what we're going to do, I'll just do it in one calculation, equals 4.4 minus the mean, and divided by the standard deviation, 0.5. As usual, I'm pointing and clicking, not typing numbers whenever I can avoid it. Oh, it doesn't like my formula. I made a mistake. 4.4. I forgot to put a parenthesis in. Shame on me. And I better get rid of that parenthesis or it'll squawk again. Okay, that's telling us that the point we're interested in is 1/2 of a standard deviation to the right of the mean, right there. So I got another little picture I'll bring in if I can. And I'll point right in there. We're going to get kind of confused, but the point we're interested in is right here. Now, we're interested in the amount to the left of that, less than that. So we go to the table on page 251 to the 0.5 column, and we find a value of 6915. And that's the probability that we're looking for. We don't need to subtract from 1 because the table gives us the area to the left of the z value. That's the probability of getting a bank whose spread is 4.4% or less to the left. Okay, the third part is to work backwards. Once again, I went up too far. Let me get we can see our values here. Now, it's asking us to find, this particular bank now wants to be the low-cost provider. It wants to set its spread so that no more than 5% of all the banks in the United States have spreads that are less than its spread. It wants to be the low-cost provider. Okay, so we know already the area under the curve wants to be, well, it's not 95%. It wants 95% of the banks to have a higher spread. So what we really want is the opposite of that. We want to find the probability of banks being less than 95% or 5%. So we want an area under this tail that is no more than 5%. Okay, so that's our end point over here. I'll put it in right over here because that's where we've been putting percentages, 0.05. Now, whoops, 0.05, sorry. Now, what z value corresponds to an area under the curve of 0.05? Well, what we need to do is to take the book, table 6.1, and do a manual scan here. So we're going to look down through here and find a value of 0.05. If you go down, look around minus 1.6, scan your eye over, somewhere between 0.505 and 0.0495, so halfway in between those. So we're going to have a value of 1 minus 1.645 is the z value. Minus 1.645. Okay, what is that telling us? It's telling us that that would be right in here somewhere. I don't have a label for that one yet, but we'll just imagine it's there. 1.645 is right in here. We want a spread that is 1.645 per standard deviations to the left of the mean. So to find that percentage, that spread, what we do is we take the mean, 4.15, and add to it, and we're adding because it's a negative number already over here, that many standard deviations times the size of a standard deviation, which is 0.5, or 3.3275%. If you offer a spread of 3.3275%, then no more than 5% of the banks in the United States will have spreads that are less. Put it another way, 95% of the banks in the U.S. will have spreads that are greater than that. Now, some people might say, wait a minute, Instructor John, what happened to the empirical rule? 95.44% of all values should be within 2 standard deviations of the mean, right? Well, this is 5%, and we're only 1.6 standard deviations. What's going on here? Well, the empirical rule says that yes, 95% of the values will fall within 2 standard deviations of the mean. But remember, that means that some of them are going to be greater and some will be less. So the area of this tail will be half of 5% or 0.025. The other half of the 5% will be up here. In this problem, we have a single-tailed problem, so all of the 5% will be in this lower tail. Okay, that's all the time I have for this video. We'll see you online.